about stuff very soon. Just give me like a minute. So I gotta actually get to it. Alright. Play Tricolor and PBs and hi. Hey Harry and Jack, what's going on? It's a more serious type of stream, but what's going on, man? Also, how did you play Tricolor and PBs? How did you play it in PBs? Like what was like what's the what type of format were you guys using? Did you guys like put like two people on different teams? Like you have one full team and then you have two people on the same team but on the other sides of the map? Is that how you guys did it? Just wondering. Also, hey Don, what's going on? Wait, this is not Splatoon and I am friends with a hacker? Okay, yeah. It's not Splatoon if you read the title. Not sure if you did, but it's okay. Not sure how I feel about you being friends with a hacker, but that doesn't sound so cool. Alright, so big things happening. This just happened. Tropical Storm Franklin now exists. Have Emily. 6 is still here. I believe this is Franklin now. And we still have this to watch, so a lot more stuff on the board today for tropical weather. I'm gonna get to that. Then we're going to get to fires, and we're going to get to COVID stuff later. You clicked on the thumbnail. Oh, yeah. I need to update my thumbnails. I actually have to make thumbnails now because I had that Splatoon 3 one from like last year. That's what I put as my thumbnail for all of them. So I have to change that. So I have to start actually making thumbnails now. If you guys have like good like application I can use to make thumbnails, that would be great. That way I can actually make them. I can make them so you guys can get a better idea what stream it is. I hit Executive VP and I'm at a stalemate. Oof. What's happening? You getting bad teammates or like the Salmon waves are just too hard? What's happening? Alright. We'll look at the Eastern Pacific first. Forgot to put in a Storm Prediction Center, so get that. Storm Prediction Center. There we go. Just open this up, shove this to the right, to the left, actually. Come on, open up. It's taking an extremely long time, my bad. It's more severe weather. This is from Hillary. It's over to here. Yeah, there we go. Alright, I think I have my setup now. I have all these tabs up here that we're going to be looking at. If you have any questions, I can just look down. Alright. Hillary is now over, I believe, land right now. Hillary has gone over land, so I think that spares San Diego and this stretch of Southern California from flooding off the ocean. So the wind should be moving offshore. So because the wind's moving offshore in this area, flooding should not be as bad in the cities. So the water should be able to escape more easily. So that's good. He's seeing rain. Yeah, I know. It's moved up pretty fast. It was down here yesterday, but it's moved up here now. So, tropical storm is weakened down considerably. Still 60 miles an hour. But the main issue is rain. The winds have died down. I did see a video of like heavy flooding in like Baja California. I have to search that up on Twitter somewhere. I have to get it. I think I can actually search it up on Twitter now, but I'll search it up in like a bit. We'll get to the weather first. So Hillary's here. It's going to continue moving up. Its wind field is still large, so there's already tropical storm force winds in Southern California right now. So as the night continues, it's going to continue moving farther north. Most of the rain hasn't gotten it there, though, I think. The rain is falling, but the heaviest rain is still farther south. It should be getting in Southern California right about now. If we look at rain that's still to come, so less rain in Baja California that's still to come. But if you live in California itself, in the mountains especially, there's still, on top of what you already had, like the 2 to 4 inches of rain you already had. Well, not 2 to 4, 2 to 3 inches you already had. You'll get another 4 to 10 on top of that. So like Southern California along the coastline, you still have another 1 to 2 inches to go. But in the mountains, you still have a lot more rain coming. Especially, I think this is where San Bernardino is. Still got 6 to 10 inches of rain coming, as well as in the mountains up here. This rain is still coming. So the worst of the flooding should begin like overnight and into tomorrow morning before the storm fully moves northward and the rain begins to lighten up. So the rain's still gonna. So most of the rain still has to fall over this area. Look at the Storm Prediction Center, which I think it's here. The heavy rain is already starting to move in. Heaviest is still a little bit further south, but it's already moving in. So the flooding that is coming was starting right about now. So we'll see its full effects in about, I think in about like 6 hours. We'll start seeing it. There's plenty of flash flood warnings around here, I believe. So the heavy rain's already ongoing. So I would stay inside if you are in Southern California right now. I'd stay inside. I wouldn't go outside anywhere. If you do have to move, like if you're on a mountain and you know like you have a feeling it's just going to be a landslide or something, I would move. That's what I would definitely do. I would move and try and move somewhere else where it's less dangerous. But the heavy rain is already falling, so I wouldn't recommend it at the moment, unless you absolutely have to. So we'll look at a time scale of it from a forecast model perspective. Rain's already falling in these areas, so we'll look at a mesoscale model. Look at HRR, and we'll zoom into the southwest. And we'll go back 4 hours. So the storm is around here. Already heavy rain in Southern California. Move it like an hour at a time. The rain continues as the storm quickly begins moving northwest. Now, this wind direction, since the storm is here, you might get some flooding on the back end, in like San Diego, since the wind's coming across and pushing on the shore here. So it's moving offshore here, but in this area, it's going to be slightly pushing onshore. So that might worsen some flooding that is here. But it shouldn't be too bad. And then the rain continues. In about 9 hours, it's still raining in Southern California, but it begins clearing out. And then the rain shield moves north into the Sierra Nevada, which is here. If you need a drawing, Sierra Nevada's like right here. Into Western Nevada, continues moving up, actually. And then it moves, the rest of the storm just moves northward. And the heavy rain dissipates. But there's still some heavy rain in like Idaho and eastern Oregon up here. But by tomorrow, like afternoon, in these areas, the rain should start clearing up. It's not a hurricane anymore. It's a tropical storm now. It was a hurricane earlier today, but it's a tropical storm now. But yeah, that rain moves northward and then pushes out over time. So that remaining 4 to 10 inches of rain that they're gonna get over here is gonna fall between now and like tomorrow morning, and then it should clear out. The only issue is how much of that heavy rain over there, because I believe it's like 2 o'clock over there. How much of that heavy rain comes down in certain areas will matter a lot. Because if they get the wrong band setting up on one of these mountains, flooding could be a lot worse in one area compared to somewhere just like a few miles away. Kind of thing. So it really depends where these bands set up. So I would check a radar if you're here. So I wouldn't really call it a forecast, but you have to really do nowcasting. So if you live here, you would have to check where the rain is falling. And if you do have a flash flood warning, get to higher ground. If you feel like it might be time to leave, I will only do as a last resort, and that will be it. So just stay safe over here. That's all I will have about this update, at least for the rain. But just watch out for that, and stay tuned and stay up tonight. And when the rain clears out tomorrow, look outside, check for flooding, and other stuff that's happening. And other stuff that's happening in your local area, like using your local officials and stuff. And then begin repairing the stuff that you have to do, that you need. So we'll go over to the Atlantic now. That's basically it for Hillary in terms of rain, but I would just stay up and track it if you live over here. Where is it? Should be home menu. Alright, here we go. 1, 2, 3. Yeah, Franklin's here. Just updated the map. 6, Emily, and... Oh, this is a 60% chance formation now as well. Interesting. Look at the 7-day. Yeah. This is a lot different of a map than it was yesterday. Tropical Storm Franklin now exists. So, okay, we'll talk about the Gulf system first. I mentioned 6. This doesn't seem like it's going to strengthen. But we'll talk about Franklin. We'll talk about the Gulf system, and then we'll talk about Emily and this system afterward, and then we'll get to 6. So, we'll talk about Franklin. So, they say Franklin's is forecast to approach Hispaniola late on Tuesday. So, right now it's Sunday, August 20th, up here. If you guys don't know. This is the date and time. This is in EST. The time over here is at Atlantic Standard Time, I believe. Okay. Just listening for Mom to make sure she's not saying anything. This is important. Franklin's forecast to approach Hispaniola late on Tuesday and move across the island on Wednesday as a tropical storm, bringing a risk of heavy flooding from rainfall and strong winds and dangerous waves along the coast. So, as the storm moves westward, it doesn't look like it's going to strengthen too much, like I said yesterday. But the fact that it's moving in this general area and then it makes this turn and hits Hispaniola on the southern end, the amount of rain that's going to come out of this is going to be very severe because you have a storm that's moving, picking up a large amount of moisture in this area, and then it's transporting that moisture over mountains, which will really start wringing out the moisture that's here. So a similar thing that's actually happening in the west right now will probably happen here. The only difference is that the actual winds will be stronger, and the storm might be strengthening as it approaches land. And plus, you'll have the storm surge issue as well. So heavy rains are expected. Expected across portions of Puerto Rico, which is this island right here. No, I need to make that bigger. Puerto Rico is this island. No, I'll just put a dot over it, actually. Puerto Rico is here. That's where Puerto Rico is. Hispaniola is the island where the storm is supposed to go directly over. And there's 2 countries on the island, which are Haiti, which is the western side, and the Dominican Republic, which is the eastern side. So, as it says, mainly across Hispaniola, significant and potentially life-threatening flash flooding is expected, possible on Tuesday and into Wednesday, due to the heavy rainfall. So, if we're talking about like heavy rainfall, I believe there's supposed to be 6 inches of rain that falls here. I'm not sure. I think it's 4 to 6 inches of rainfall over mountainous areas. Hold on, I gotta close the door because Mom is here now. Alright. Let's close the door. So yeah, heavy rain. We'll look at the rainfall potential. This is only for the United States, though. So we have to look at the models, unfortunately, for rainfall potential. We'll look at on Puerto Rico. It seems to be that they're gonna get on this eastern part of the island like 46 inches of rain from the southern part, which I believe the mountains are right here, and then on to the eastern part, 46 inches of rain. This can be significant. On this northwest side, there's going to be 1 to 2 inches. So this shouldn't be as significant, but most of the rain, so most of the island gets about 2 inches of rain or higher, especially in this mountainous area. Also, good games for you guys, by the way. So you get heavy rain here, because the wind is pushing in like this. So as it hits the mountains that are here, that's gonna get the rain to get rained out. While on this side, there's less rain because the wind's pushing away. It's not gonna be as much moisture that's gonna be pulled out of the storm. Well, it's not gonna be a emphasis for the moisture that's here to get forced up and turn into rain, like there is here. Because if it's hitting a mountain, it's forced to go up. So that's why it's going to be less rain on this side of the island compared to this side. Got a bit too hyper. On what? Are you guys talking about Samron or are you guys talking about the forecast? So yeah, that heavy rain is mainly going to be concentrated on the southern end of the island. The Virgin Islands over here are supposed to get 2 to 4 inches of rain as well. Obviously, not the same amount as the island itself because there's no mountains to actually force this to force the wind to go up. But you're still going to get 2 to 4 inches of rain, so that's pretty significant. If you do get a thunderstorm over here that gets it to fall faster, you'll see some flooding. But the flooding here should not be as bad as it is farther west. Shouldn't be, at least. That can obviously change, but it should not be it should not be as much of an issue on the islands over here. Go look at the cone. So tropical storm force winds. By the time it should be a tropical storm all the way here, and then it looks to be a hurricane after it exits the islands. We'll see how that goes. In fact, I need to try and actually get the discussion, because the discussion usually tells the strength. Yeah. So over the next 48 hours, it slowly strengthens from a 45-mile-per-hour storm, which it is right now, to a 50-mile-per-hour storm, and then a 60-mile-per-hour storm, and then right before it hits land, it will be 65 miles per hour. I think if it can get its act together a little bit faster, it could probably be closer to 75 if it can get its act together faster. It just really depends on how the storm organizes its structure more. I think that's just the main thing it has to get through. If it organizes its structure pretty quickly compared to where it is right now, and actually gets that convection wrapping around its center, it will get to the 60-mile-per-hour level faster than it says here. Because I don't think it will stall its intensity barely intensify for a full 24 hours. If it gets itself together earlier, this will definitely increase. I'll say, hey, Kappa, what's going on? So it just depends on how fast it actually organizes. Really. So we'll look at a model for that. We'll switch to I can't use this model. I have to use a global model. That model is only for the United States. All right. Let's go to the Western Atlantic. Okay. This is where Franklin is. It's not showing up too well in the models, unfortunately. Because usually the global models don't tend to catch up on stuff like this. They don't catch up on smaller systems. They pick up on bigger systems usually. They don't tend to catch like small disturbances like this. They don't catch these really. They don't build them up too much. So we'll take that out. Take this out from initialization because I can't do 0 hours. I have to do 6 hours. So we'll take that out by a little bit. It moves westward. It gets heavy rain on its eastern side. There's still some dryness off to its northwest. So 24 hours would be about, this was the 6Z run, 18Z run. So that would have been 3 hours ago. So it would have been, the storm came out 3 hours ago. The storm center drops to 998 here. The Gulf system gets stronger on this model. Vista didn't show up yesterday. So this could be another tropical storm as that enters Texas. We'll get to that. And then as this storm gets closer to Hispaniola, it ramps up within that final 12 hours. Because see, like, it starts here. Well, no, it doesn't start here. Let me move back. Like, once it gets to the 48-hour mark, it gets heavy rain around its center. Like here. It gets the rain around its center. And then as it keeps going, and then as you keep going, the storm moves northward a little bit. And then it strengthens as it does so. And that heavy rainfall area wraps around the center a lot better. So the center itself is directly underneath this heavy rainfall. So the storm's able to intensify quicker as it gets closer to land because it gets organized once it gets here. So I think the main thing is going to be Does it get that? Does it start organizing, get to a point where it organizes down here? Like closer. Let me actually draw that bigger. Yo, oh my god. I don't like this pen feature. Does it get organized down here? Or does it get organized like it says around here? Because the faster it organizes, the faster it organizes, the stronger it's going to get here. It just happens to organize within the last 12 hours, and that's how you get the 60-mile-per-hour wind reading that pops up on the NHC forecast, because it's in a low state for the next day or so to organize itself. But then once it gets there, gets that organization, then it starts actually building itself and getting stronger, noticeably. Not super strong, but it gets noticeably stronger. And then on hour 66, which is the farthest out, it makes landfall and hits Peninsula, and that brings a lot of heavy rain there. It's a lot of heavy rain. So, this amount of heavy rain is going to become a large issue. So a lot of these mountains are going to be covered in this heavy rain. We could look at the precip just over like this short period of time. And yeah, even in this short period of time, you're getting what? In like the next like less than 3 days in this area, if I just back this up by like a little bit, you're getting, okay, let's get to like 30 hours. So you have basically no rain here. So in about a day and a half, you're getting 6 to 10 inches of rain or more in less than a day and a half. Like that, even though the storm isn't too strong, that amount of rain, like this amount of rain in under like 36 hours is a lot. Like that ground is not going to be able to absorb that water that quickly. It's not going to be able to do it. Like that rain's going to be falling. It's going to be falling hard. That ground is not going to be able to hold that much water if it comes down that hard. Yes, these are tropical islands and all, but that much water falling in that amount of time, it's not gonna bode well because it's falling in the mountains first off, so it has to run down. Number one, and the soil is not going to be able to absorb this much water as fast. It can absorb a good amount of it, but it's not going to be able to absorb enough of it to stop flash flooding. And if you're like in one of the cities around here, that's definitely not absorbing the water at all. Because concrete, for example, right? I'll draw something using this thing. Concrete doesn't, let me actually fix that. I'll use the whiteboard, and I'll use this color. Like concrete, let's just say this is your road, for example. It's your average road. It's made of asphalt. It's your average road. It's your average road right here. If you're getting water or like just rain in general to fall on top of this, like the amount of rain that's falling down like super hard, that rain cannot easily soak up. If I use this color, there we go. That rain is not going to easily soak up into the ground. Let me actually delete this and have a diagram here. I have rain here. Just have rain across the entire screen. But on one side we'll have grass and trees and sand. And on the other end we'll have asphalt, concrete, and stuff like that. Try and draw it the best I can. So this will be your road. This will be your local sidewalk. This will be like baked sand in the desert. Continue. This will be like swamp grass or tropical forest grass. I like a tree in here somewhere. This is it's like a prairie grass right here. And we'll add a green here. This is just your normal grass, your plains grass, stuff that's not in your forest. This could be forest grass. This could be stuff in the plains, like next to a forest. This is like deep, like dark forest, like temperate stuff. Not temperate, like tropical, like swampy stuff. Heavy rain forest. And then mountain. Mountain doesn't really qualify here because mountain can be either one of these, except for these two. Oh, black could also be It's actually a good. It's actually a good one. You can use this gray. Okay. Or you have this gray, which is fire. All right, fire. So we'll test it out. All 1, 2, 3, 4, 5, 6, 7, 8 of these surfaces, and then I'll get a nice brown to just picture what the dirt will be underneath here. All right. Okay. All right. So this might take a while, but we'll see how it goes. Drawing takes a bit of time, guys, so hopefully you guys are doing something while you're watching me draw, because education might not always be fun to watch, unfortunately. It's how it tends to go, unfortunately. So, yeah, I think we'll leave it like that. I'll cover up some more of these white areas. I'll put some water and some roots in here eventually. We'll get that out the way. For just explaining what it looked like. All right, so this is our canvas right here. So here's your rain. We'll get like this gray up here. Get this gray to produce the rain. We won't add any lightning. We'll just say it's just like regular raining. Just say it's like regular rain. Maybe some snow on here too, but this is what we'll look at. Okay. So, I'm going to use this water. And we'll shrink this down to around there. So, on these surfaces over here, water cannot permeate through the ground. So what I mean by this is that any water that falls on top of this surface is not going to be able to get through it very easily. Like if the water's falling, use pink here, the water's falling on top of this, it's not going to be able to get into the ground and then move somewhere else to like maybe where there's water, a pool of water, underground river. It's not going to be able to do that. It's not going to be able to do that like it would here or something. It's not going to be able to do that. It just can't. I mean, like, yes, it could. I mean, like, yes, you might get, like, enough water falls on top of this, and then it breaks, like the concrete example, as water concrete, or it just, like, seeps underneath the ash for some reason from fire. But as a general rule, any real rain or water that falls on these types of surfaces doesn't usually get through. Is different than desert. In desert, and sand over here and just dry grass. This is different because you can have rain fall on this and this can be absorbed. It just can't fall too fast. So as long as the rain here doesn't fall extremely fast, the ground can absorb it. And if you get enough rain here, then it will be, especially on like this dry grass thing, if you get slow rain here, it will slowly build up pores in the soil, so where it can become more like this grass over here, which can absorb water fairly easily. But this stuff over here will not absorb water, so any water that does fall off, well, any water that does get here, for example, any water that does get here, you're just going to pile up in these areas. It's going to pile up, for example. I wish I can draw better. Just going to pile up, and it's going to move somewhere. So it's going to move either down that way. It's going to move down that way. It's going to move anywhere. It's like low-lying areas or where it can actually feasibly go. Over here, if you get rain that falls here, as long as it's not falling at heavy rates, you'll get some of this rain to get inside the soil. Not a lot of rain. Not a lot of water is going to get into the ground here and then down here eventually. Not all of it is going to get down here, but some of it will get down here. And if it falls light enough, eventually it will become like this, where there's a lot of water down here. It's a lot of water that's in the ground. Eventually, you'll get to that system. But if it's been, the sun has been out too long, or it's been like a little bit too hot in these areas, like you have the sun just been scorching this ground for a long time, then whatever pores you had in the ground for the water to actually get into the soil, they're not there anymore. So water that does pool up will just do the same thing it does over here, and will just pool on top of the surface if it rains too hard, or the ground is just too dry. Over here, though, if it rains heavily, especially if you have like trees here, I can draw a tree. Not the best tree drawer, but I can draw a few trees. Let's get a few trees over here. Let's get a few trees. Let's get a few trees. There we go. Let's get a few trees. Like, yeah. If you can get something like this, a few trees over here, vegetation like that. Hi, what you doing? I'm talking about like weather first. I'm trying to explain like what how rain absorbs into the ground right now. To explain like this part, where I'm talking about the amount of heavy rain that's falling over Dominica right now. It's gonna fall over Dominica in the next 3 days. So I'm using this to explain this and how water gets absorbed into the ground. Thanks for being here, by the way. But yeah, if you get like heavy rain here, as long as you have like trees and enough grass here, this water should be slowed down enough so you're not going to get like intense flooding where it overshadows the banks like that. That shouldn't happen. As long as there's enough vegetation to slow it down, this shouldn't happen. Now, if it falls too hard, then yeah, you're still going to get flooding. But it's not going to be as bad as it would be like over here, for example. Because over here, this ground can't hold much water anyway. Over here, the ground can hold water, yes. It can hold a good amount of water. As long as it's not all coming down within like a day or two, it can hold the water. And it can push it up so where like you have rain, the water comes into the tree's roots, and then it gets evaporated back into the atmosphere like that, or the groundwater just runs off to like the ocean or somewhere. Most of the Caribbean islands are like this, so they get heavy rain, but it doesn't usually cause flooding because the ground can actually absorb the water. The only issue is when you get flooding is when you get this much rain within like a day or two, because the ground can't hold the water and then it just floods everything. So that's a scenario where flooding will occur here. But in normal circumstances where they just get like a normal thunderstorm, you wouldn't get flooding usually. in that situation. So the main impact here is not going to be wind for the Dominican Republic, it's going to be flooding. So wherever this center goes and how much convection it gets with it, that's where most of the worst flooding is going to be. So especially on like the south side of Dominica, I don't know what cities are here because I haven't been here. I don't have the map of it like somewhere around here yet. I can pull up one, but most heavy rain should be in the southeastern part of the country. That's where the heavy rain will be. And then as the storm pulls away, you get some more rain here, but it doesn't build up as much. So once the storm passes by, there should be some efforts to recover. But just like if you get the heavy rain like in California, for example, in the mountains you're still going to get landslides and the flooding to do terrible damage. So if you do get that to wash out roads or something, they're not going to be able to rebuild as quickly. Because water damage stays around for a long time, whereas wind damage can be cleaned up fairly easily. So if you have water damage, if I go like here, go back to this thing. If you get water damage, like water's going to stay high for a good amount of time. Like if this becomes flooded, this water will stay here for like, I believe, for a few days. And if you like added like a city on top of this water's going to stay here for days. So you're not going to be able to actually do any sort of recovery or anything until this water goes away. And then you have to recover and then rebuild everything, for example. Whereas over here, if the waters like move out, yes, it will move out, but it's hot enough, using like the desert area, for this water to evaporate and move somewhere else. It's hot enough for that. Same thing here, but this ground will be heavily saturated, so the water will still be here. And you'll most likely get another one of like these rainstorms to come back in these same areas, so it will just keep raining. So the more of this rain you get, even if you already have flooding on the ground, if you get more rain afterward, it's just going to keep this here longer. It probably won't worsen it, but it'll just keep it here longer. So that's what I would say. As long as the rain falls, if it falls heavily in these areas, it just depends where it falls heaviest, really, to really understand what the impacts will be here. So I'd watch out for mostly heavy rain. If you know we're in a flood-prone area here, I would move out of it. Because this heavy rain of about 6 to 10 inches or more in like 36 hours is going to be very bad. Very bad. Although that's putting it lightly. It would be terrible. Because I believe Tropical Storm Erica in 2015 did a similar thing. And there was a lot of flooding. And that was a humanitarian crisis here. So the rain's really going to be an issue. So we'll see where the storm center gets in the next few days. But I'll keep an eye on this since this will be very important. Hope that explains like the flooding thing. But at least for I think how much rain this land should be able to absorb, this land here should be able to absorb at least, not most of the rain, it should absorb at least like 3 or 4 inches of the rain. It should absorb that much rain, and then the rest of it will run off. Depends how slowly it falls. If this rain falls slower in some of these areas, flooding won't be as bad. But if it falls down faster, or this area is already saturated, which I don't know yet, but if it's already saturated, then flooding will be a lot worse. Really just depends on how fast the rain falls here. I can use the hurricane model for this actually. This one. This is 6L. They don't have Franklin yet. That's unfortunate. We'll use a different model. We'll use ECMWF. Same thing for the Euro. You still get heavy rain in the Dominican Republic. It's just shifted further west. Now, the more of this rain falls in Haiti, it will be an issue because Haiti doesn't have as many trees as the Dominican Republic has. So Haiti is a lot closer to, if we're talking about the rainfall graphic, it's not this. For most of Haiti, most of Haiti is more of this type of grass. So it's not going to be as effective as reducing rainfall as a jungle would be. So because it's not as effective as a jungle, flooding will be more of an issue here. Be a lot easier to occur, and the mountains are not going to make that any better. So on the Dominican Republic side, they have the advantage of having the forest to be able to store and hold the water back to a degree. In Haiti, they don't have that. So any of this heavy rain that does fall, it's more likely to actually flood this area out. It's not like this over here, but it's more likely to flood since it doesn't have as many trees to block it. Or like swamps or wetlands to do it for them. Also check like the CMC. So this happens within the next 3 days. Check the CMC as well. Yeah, CMC has more rain. It's still in the southern part. This seems to be the general trend. So if that's where the storm center is by the heaviest rain, then there should be a consensus. The storm center should be somewhere in here within 3 days, which is about 72 hours. Because it really starts ramping up within 72 hours. So it should be somewhere in this area, really. And then this moves westward. And then after that, it strengthens out here. But we don't know what's happening afterward from that point. Still also some rain off Central America. Some rain from that tropical system as well. So we'll keep an eye on these two because they will also affect land. But as a general rule, the amount of rain that's coming out of this, I would pay attention to it if you live in the Dominican Republic. And then afterward, we'll see what it does. But the flooding will be the main issue here, so we'll keep an eye on that. So I'll probably try and deliver like another update tomorrow. Since I'll probably be able to do it when we have a little bit more information and it's closer to the actual event itself. What else was I supposed to talk about? Alright, the Gulf system. We have to move up to the Gulf system up here, and then we talk about the other three. We'll move up to the Gulf system. Alright, so while that thing's developing, the Gulf system over land, so we'll scoot this back 40 hours. The storm is here right now. It's disorganized. The area of interest is here. At least no. If I go on back on the map, it should be somewhere around this area. If I go back to the home menu, it should be there. Yeah, it's here. I knew it was here. I was just a bit confused because it says 6 hours ahead. Yeah, so the interest is here, and it's supposed to be over here within 48 hours. I think the thing for this storm is like how fast does it get itself together? Because it moves over the Gulf, but it doesn't start getting its act together until it gets here. Until it gets like 30 hours out south of Louisiana, as it's approaching Texas within the final hours. So within this final 12 hours, just like this storm, it gets its act together within that final 12-hour phase. So it's disorganized for most of its journey. But once it gets here, it has 12 hours to actually do something. Get its wind field closed off and actually start taking advantage of what it has for it. Now I can look at wind shear to see if it has the potential to actually do it. It doesn't have much wind shear over it. It has a good like outflow, especially like this eastern side has some good outflow to it. There is some shear on the western side, so that's probably going to inhibit it a little bit. It's not terribly strong, but it will inhibit it just because it exists. And then it moves westward, and it's on the tail end of that shear, and then it moves into Texas, as that shear from the ridge just forming over the United States really starts cutting over it like a knife. So it has the potential to organize in the next 30 hours because it has a somewhat favorable winter environment, especially if it's farther east. But it really just matters like if this stays underneath here, because if it moves too far west, it's not going to be able to strengthen because it will be underneath this shear. Really just depends what it does here. Also look at dry air as well to see. I guess two things to get for it. It needs its center to form underneath this moisture and stay underneath this low area of shear as it moves westward. And by the time it gets westward, it needs to keep all of this dry air up here out of its circulation. It's a little bit of dry air on the bottom end, but it needs to keep this dry air out of its center for it to really actually strengthen. So when it gets within that final 12 hours, there's already some dry air getting into it, so it doesn't intensify fast. So it doesn't ramp up quickly because there's dry air inside of it. But the only thing it really needs to do is have that light wind shear environment, really. So if it has that light wind shear environment, that dry air can't get in as easily. Because the wind shear would be pushing over it like this. So it needs to be eastward a little bit. It needs to develop a little bit faster to prevent this dry air from getting sucked into its center and slowing down its development. Still be a heavy rainmaker in a tropical storm when it gets here, possibly. But if it really is trying to get itself together, for it to really be notable, on this, at least on the satellite and from the weather perspective, it needs to get itself together here. So when it gets here, even though it's still going to have conditions to develop, it won't be as strapped for time because here it has land interaction to deal with too that it has to get through. Because land is not good for tropical cyclones either. Because land disrupts their wind flow and makes the wind slower and has dry air over it usually. That's not good for it. So if it's really trying to get this 1004 millibar low it has, it's about a week. It's a weak tropical storm. Still has a lot of moisture with it. It really needs to get this close center, like here, or at least like a further east. It needs this close center earlier for it to actually really do something here. The less likely it does that, the better it is for conditions wind-wise over here. It won't really change the rainfall impacts though. If I check like the accumulated precip, doesn't really change the rainfall just again South Texas. You'll still get about 2 inches or more from the storm in this area, which is good because you have a drought here. Any rain that you do get is good, no matter what happens. That's good for you. There's no rain up here because of the ridge, but any rain that you do get down here is beneficial, and it doesn't seem like it will fall like super fast. So this is a good rain. It's not this type of rain. This type of rain you don't want. You want more stuff like with this type of rain. Good amount of rain, but it's not heavy and it's not all at once. Stuff like this isn't beneficial. And then that should move westward and should probably like enhance the monsoon over here. Bring a little bit of rain to the desert southwest. Okay, let's zoom out. Let's get to let's go to the full North Atlantic. We'll check the actual satellite imagery first though. I believe this is Emily. No, let me move back. Yeah. Emily is this one. Emily's here. Franklin is this area in the Eastern Caribbean. Tropical depression 6 is here. Gulf system is here, and that other storm that's coming off, tropical wave that's coming off Africa, it's right here. If I look at this, it's right here. It's supposed to be moving over this general area for the next 7 days. So we'll see what that does. Look at satellite imagery. We'll just use the Atlantic floater so we can see everything. On tropical tidbits. I could have used the Atlantic East-Pac combo. That's not going to give us the entire Atlantic, so we'll use this one. My nose. Okay, so I'll pause it here. Convection. So this right here, this graph scale over here tells you how strong the convection is, because stronger convection tends to go higher up in the atmosphere. So if it's like colder, like down here, there's really strong convection. So Franklin has strong convection with it right now. So does Emily up here. 6L doesn't have that much strong convection. And that tropical wave that's coming off Africa at the current moment doesn't have much convection that's very strong with it, but it has enough to where it can actually like be noticeable and organize itself. And there's that Gulf system over here. Now, we'll keep looking at the loop, trying to see for any patterns. Franklin has that. This is like 3 hours, right? I think that's 6 hours. Yeah, it's about 5 hours. So Franklin has this consistent deep convection with it. It's not over its center directly, but it has consistent deep convection. So this is definitely starting to get on its way to actually organizing as it should be. Emily up here has some convection that's relatively sustained. So usually if you're having a tropical cyclone, just go back to this graphic and this. You have a tropical cyclone. The convection, which would be thunderstorms, needs to be like sustained for at least like 6 hours or more, usually, for the storm to actually start getting stuff done. Now, why is that? Because if thunderstorms last around the storm for more than 6 hours, usually that means that the storm has enough air that's coming into it, and there's no dry air infiltrating the storm. Because if dry air infiltrates the storm, what usually happens is that the storm strengthens and blows up, yes, but as you get dry air, let me use a different color. We'll use brown. As dry air gets ingested into the storm up here, as this dry air gets in, that's going to get pulled down to the surface, and what you're going to get is that you're going to get an outflow boundary like that pushes the rain-cooled air from the storm outwards, and that kills off the storm. This is not what a tropical cyclone wants, usually. This is not what it needs for its continuous survival. It needs this thunderstorm to stay like this for a prolonged period of time. You have ups and downs, yes, but this needs to stay here. So you need wind that's coming off the ocean, which is down here. The ocean has to be warm, but you need wind that's coming off this ocean down here. This wind needs to keep moving into the storm like that, and the storm needs to not have a downburst that's taking dry air or winds from up above in the storm and pushing it down. This needs to not happen. Like, this cannot happen for a tropical cyclone to get its act together. It needs this. It needs this. These arrows right here needs to be constantly fed energy. Because once it gets its energy constantly fed in, then temperatures up here increase. It has more moisture to work with. The thunderstorm can continue. Because thunderstorms can continue, but pressure lowers here. So you get a low pressure that forms here. So that pulls in more air, and that forces more of us up. These get stronger, and they wrap around the center, usually. And this cycle continues. At night is strongest because up here the air cools, but the water still stays warm. So this is strongest at night and is weakest during the afternoon. And then the storm continues to get stronger. The low pressure stays here, and it organizes itself. So you no longer have. If I go to the animation, you no longer have where it's just organized like this, and you have convection like that. You have it where it's more like, if I were to look at Hillary on like a previous satellite imagery, if I can find it, probably use a forecast model for this. If I can look at East Pacific, and we use thermodynamics, similar IR radar. Yeah, move this back. Let's go to the agency run from Thursday. Let's go back a little bit further. Let's go to 0Z run Thursday. You get away from this organization, and you get these thunderstorms that wrap around the center. Once that happens, the storm can actually get its act together and start doing stuff like this, where it gets that eye wall to come out, it gets to clear out its eye, so the sinking air gets into the eye. So as the eye warms, the storm's getting stronger because you have more heat that's being built up inside of it, and the air's being sucked down. So that's what you will look for. As the storm gets away from that disorganization phase, it turns from not there. Why did I go there? I didn't mean to go there. Let me get rid of this. it turns away from a disorganized group of storms, where you have storms like around the center, like this. It's not the best system, but if storms like this or something, they're disorganized around the center. They're trying to do stuff. You have maybe like your monsoon trough is like down here or something, but the storm is turns from disorganized to something where it's more shrimp-like, where it's like half a storm almost, like someone like this. It's more of a shrimp-like shape usually. It's all gray, but it's fine. System that we're using right now. The storm turns into more of a shrimp-like system until you get like banding, where you get two hot towers on either side of the storm. You have some sort of eye wall that's trying to form. That should go back. We can use some sort of system like that. You can get some sort of eye wall that's trying to form. It's not fully developed, and then you usually get the donut eye when it's actually like a full storm, usually. So it gets away from the polka dot phase of like the sporadic convection that like Franklin has, like actual satellite imagery, like what these storms have, until it gets an actual like organization that it needs to actually develop itself. So we'll go back. So you already saw the satellite imagery, so we'll go to the forecast for these things. They don't seem to affect land really, but we'll see what happens. Tropical Atlantic, get rid of that. So using GFS, we'll use 3 models here, and then we'll switch over to smoke, and then eventually the big thing that I wanted to talk about. So just like that, the Gulf system and Franklin do start developing in their respective areas. That Gulf system moves into Texas, bringing us heavy rain. Franklin moves into Hispaniola and drops a lot of heavy rain within a short period of time. Makes landfall, but the mountains don't really shred it as it starts recovering immediately after it passes the island. This storm, I believe, was Emily. Yeah, that's Emily. Emily moves up. It's pulled up by this storm, by this mid-latitude system up here. So because Emily is strong enough, it feels the pull of the storms up here, so then it gets dragged north with it. Same thing with Franklin, but it misses that opportunity. And this storm, which is that wave that just came off Africa, it's a hurricane, so it moves westward, while Franklin is over here. And we'll move it out to 160 hours at best. We'll stop there. So Franklin's almost a major hurricane here, as it's in the open Atlantic, closer to Bermuda. And then there's that one storm behind it. Just a little bit too far out, but that's the main like symptom of it. And then after that, it doesn't seem to be too much in this area. It's really developing. Really, there's some stuff in Eastern Pacific. Go back. There's some stuff in the East Pac that can develop, like over here. Some stuff is trying to develop. Like if I go back by like a little bit, like this storm tries to develop as well. Spins up off Central America. Get another one that tries to form later. That spins up as well. But you're not getting like more of these tropical waves that form and spin up as well. When we take it out all the way, even if we take it out all the way, doesn't seem to be anything that's really popping up here. It's like eye-catching, like, oh, we need to watch that. Maybe like this. We'll see. It's like 200 hours out, so it's not reliable. But maybe we'll see what goes on here. But it seems like the 5 waves that we do get, 2 of them make landfall, impact land, the Gulf system and Franklin. Franklin will be the bigger news story, and then we have to see what happens afterward, as Franklin could be an issue for Bermuda later down the line, and then we'll check what's happening on the East Pac in the Pacific. We'll see what's happening there. I think that's it for the tropical update, at least. Still talk about the heat. Well, the heat wave still going on in the United States that's forming now. I think I mentioned like the temperatures a little bit, so we'll briefly discuss that before we get to like wildfires. I think this is the wildfire one. No, it's this one. Yeah, this is the wildfire one. So we'll talk about this before we get to everything else I have. Alright, so let's go back to continental United States. Alright. So, tis the picture. Also, I'll also have to make sure to check what's in the chat. I have to reset my stream though, so let me reset that. Some of you guys might have asked questions that I didn't notice. Unfortunately, because YouTube doesn't update too quickly for me. That's the main issue. YouTube doesn't update fast enough for me, usually. So I have to continue to like update it and like refresh to make sure that my polls and stuff actually pop up here. Just waiting on like the chat to load. We'll get to it. We'll get to this eventually. Look at the questions. So we'll look at questions. Doesn't seem to be anything for right now. So we'll check that later. So you have. So we'll look at the temperatures first. No, we'll look at this first because this will explain. Because I can use this as another way to explain what I'm talking about later. Not this thing, not height anomaly. This. Okay, so right now there's a ridge over the center of the United States, and that's causing the high heat that's underneath here. And this ridge sticks around and continues building. It doesn't really move. At the end of the run, it begins weakening and starts moving southward as you get troughs overcutting it on the top. But even as that moves on further into the month, you get a trough in the eastern US in about a week as the ridge moves away from here. And you increase the line. Again, gotta fix this. It's hard to do. The center of the ridge moves away from here, and it's just back westward. So the heat that's over in the eastern United States right now, center and east, is going to move back into the west as time moves on. So that rain that you're getting with Hillary at the moment is probably going to evaporate pretty quickly once this ridge moves in, and it's going to be dry weather as the ridge is not going to allow any air to really. They're not going to allow any rain to really form in this area. I can actually visualize that on the whiteboard. So think of a ridge as like a cap. Not really a cap, but like a heater, for example. Think of it like that. Think of it like a heater. So you have this like large dome, effectively, of like air above you. You have, it's high pressure. So the air is thicker up here than it is down here. And this extends down to the surface as well. Under high pressure scenarios, usually what happens is that you get the air is sinking. So whatever air is up here, air from higher up in the atmosphere is sinking down on top of you. And it's just getting pulled from areas where the air is rising. So where storms are on the planet, the air rises there, and then eventually has to find somewhere where it has to sink. So this is where it would sink at. And this usually also roughly corresponds to where a lot of the deserts are, like the planet. If I can get like the Köppen climate system classification, this map. Like this map. Let me go to this. Let me open up this map. All right, explain it another way here. It also lines up where a lot of deserts will usually be. Because usually air at the equator, as like a general rule, if you like draw a line here, it's not exactly where the equator is. It's pretty close though. It matches up pretty close. Usually air at the equator is rising. It's usually rising here. So you get the air is rising in these areas, and then it eventually has to sink somewhere. Because the air in the poles is also, because the air of the poles is sinking. But it's not sinking here. So, where most of the deserts are, like you see here, 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 and here, even into Asia. We can extend this a bit. Where most of the deserts are, this is where usually high pressure is usually set up constantly year-round, because the air that's rising in the tropics from all the thunderstorms and stuff that's happening down here eventually has to sink. So it moves down here and sinks in these areas. And that's what produces the dry conditions and the clear skies. It's usually prevalent in these areas. In addition, another thing that's usually happening is that you usually have a cold water that's coming down these coastlines. So, for example, on the west coast, you have cold water that's coming down like this. West coast of Africa, cold water is coming down like this. In this area, it's not usually cold water, but you sometimes get, like during the monsoon season in India, cold water that comes up like this. In Australia, you have cold water that comes over like that. And in South Africa, cold water comes down like this. And in West South America, cold water comes like this. And this is what gives us that ENSO thing that affects basically everybody. So air is sinking in these areas. And the air above them, like if you live, we'll use purple for this color actually. Should probably shrink this area. But if you like live here, like in above this line, if you live in this line, usually, I'll draw another line down here as well. If you live like here, up to about like here, draw the lines. It's about here. There we go. It's a pretty accurate depiction of the world climate. If you live here, in these pink areas I outlined, the air is basically doing the same thing as it is as the equator. It's rising. Not as much as it is at the equator, but it's still rising in these areas. So the air here is rising. It's rising here. It's rising here. So that's usually why, if you were to look at it at a usual like map, even like during the tropics, you have a high pressure that's over like this region. At least on average, like during the summer, it's over here, usually. And then south of that, if I use red, you get low pressures and tropical systems in these areas. And then north of that, you get those normal storms that you normally see up in the mid latitudes, where you get rain, snow, or whatever. It usually passes by. So usually this is the average, like what it will look like in terms of like a hemisphere basis. In the tropics, it's raining a lot. As you move north, it gets drier, and then when you move north again, it gets wetter over time until it gets drier at the poles. So these storms give the wind shear and bring the dry air down into this area that keeps this area dry and can also affect tropical systems. So these are at the west, on the west side of ocean basins, is what picks up these storms out of the tropics when they're strong enough and picks them up and brings them up here, usually. That's usually what happens. Happens here in the West Pacific, happens here in the Indian Ocean somewhat, happens here in the East Pacific, happens here, happens out here, and happens out here. Like, the storms are getting picked up from the tropics and get brought up into the mid-latitudes that way. But during the winter, usually that high pressure is farther south. So usually you don't see rain in the tropics during the winter because of that reason, because its high pressures move farther south. While in the upper hemisphere, the high pressures move closer to the poles, so you get tropical development that way. And underneath these, it's usually, if you're in like a colder area, like if it's snow, there's snow on the ground here, this usually keeps it very cold if it's in a colder area. But usually it just brings sunny skies. But if you're in like summer, it makes it so where it's very hot down here. It's very hot. Because as the air comes down, it's cool up here, but it gets hotter as it comes down here. So it gets very hot at the surface. So it's unsurprisingly, it gets very hot down here, but you don't get rain. So you can't get rain because you have air sinking on top of you. So it's hot. So that's why if we look at like the map here, if I go to Tropics again, look at thermodynamics, underneath this ridge, it's like, it's very hot. It's 100 degrees in a lot of these areas. So go back. It's 100 degrees underneath this ridge for multiple days on end. But you're not getting rain here. You're not getting it because you can't. The air's sinking on top. So as as the ridge stays in place, it stays hot in this area for long periods of time. But until the end, like at the end of the run, you're starting to see these speckles, these boils of like these cooler colors. That's rain. That's rain forming. But until this ridge moves out of this area, it's going to stay very hot and threatening to be outside if you're working or anything in these regions, because the air is not going to be conducive to produce rainfall because you can't get rain, and it's going to stay warm at night because of like cities. If you live in a city, that concrete's going to hold in that heat, and you're not going to be able to actually rest at night. So because of that issue, it's going to be hot during the day, but when you go to sleep at night, it's still going to be very warm. So you're not going to be able to sleep. So you need AC in this type of conditions. And this is taken in the shade. So what I would do, if I were you, I would try and take, I would try and stay inside as long as possible in these areas, because I wouldn't want to be outside if it was this hot, especially even during the night. So I would stay away from the sun if you have to do any work outside. Try and be in an air-conditioned building. Drink plenty of water the day before, so you're well hydrated the day of. So when you're sweating, your body can cool down. If you're like living like further west, it's not going to help in this humid area though. If I check the dew point, like if you live underneath this humidity, it's not going to help you. No matter how much water you drink, it's not going to help you. You're not going to cool down if it's humid outside. That's just a fact. If you're in an area that's humid like this, high dew points, you won't cool down if it's hot outside. So the best thing to do is just either stay in a shade or just stay inside altogether, as you're not going to be able to make it outside in this type of heat. Without having air conditioning or whatever else you need. So this lasts for about the next 7 days, and then it slowly moves farther west. But even farther out in the mountain, like La La Land, the heat is still there. So I prepare for a prolonged heat wave here. It's already going on. So whatever heat you guys have in the middle of the country even in the south, it's going to stay here for a long time. So I prepare. So I would try and make sure that you guys are prepared for like staying inside for a prolonged period of time. Unfortunately, you might be able to go outside in this, but I wouldn't if I were you. I think that's it for the heat. So we'll get rid of this. Get rid of the weather stuff. We'll talk more about, where is it? Air quality. We'll talk about this. So most of the Eastern United States air quality isn't like perfect, but it's not terrible. But in the Western United States, it is pretty bad. This is due to wildfires in this area, or areas, as I will call it. So you have heavy smoke here. This is hazardous, so a lot of this is going to impede someone's ability to breathe easily. Like if you live in like Washington and British Columbia up here, this fire smoke is going to be pretty much suffocating. You should not be out in this type of in this type of air, because this type of, oh my god, scrolling. Just keep it together, bro. So this type of air is going to exacerbate lung problems that people have. So like in this orange, it's unhealthy for sensitive groups like people with asthma like me. So I wouldn't go outside in here. So like if you were outside in these conditions, some things you can do to stay out of wildfire smoke and like breathe properly, I would try and get a respirator with you. Bring a respirator if you can. You can buy one of these online. You need a good quality mask to keep the smoke out. So like if you had an N95 or higher mask, That should be able to keep the smoke out so where it's breathable. The air is breathable where you are, so you're not really suffocating or feeling the smoke or heaviness inside your lungs. Hey Moonlight, what's going on? Welcome to the stream. But yeah, you won't want one of those types of masks to clean the air for you so you're not getting sick from it. That's what I would do if you were around here. As well as if you can stay inside in like a ventilated house, I would. Because if you could do that, as long as you're not in an area that's going to be directly next to the fires, like up here, like in Kelowna, you need to be away from windows. Windows need to be closed, number one. Windows need to be closed. You need masks. If you see a fire coming, I will try to evacuate as much as evacuate if possible. I always say evacuate no matter what if it's a wildfire. And I will also try to make sure you keep track of like your neighbors or stuff, because your neighbors might also be suffering, and they'll probably need a place to stay, a place to get these supplies to actually help them make it through smoke like this. I can look at I can try and look at the air quality in this area. I gotta find the a smoke forecast. I can look at the forecast in this area. So we'll look at a forecast for city. What's this? City would be here. Look at the forecast for like not Vancouver, but we'll look at a forecast for Kelowna up here. So look at a forecast. Kelowna. That should be in BC, Canada. There we go. There we go. British Columbia. There. Okay, forecast tomorrow. If I zoom out, it should give me one. Seeing as laggy though. Oh, it only gets one if you're in the United States. Spokane tomorrow was gonna have pretty bad smoke tomorrow as well. So, live in Spokane, I'll also stay inside as much as possible. Even if it doesn't really matter who you are, just stay inside regardless. Doesn't seem like I'll be able to get a forecast here, but I'll look on Twitter to try and find it. But yeah, we'll look at fire. We'll look at the interactive map for fires in Canada. This is from National Resources of Canada board. Let's see what's going on. Retrieve map. Do I have to download this thing? It's not telling me. I just want like a map that will just show where the fires are, bro. I just want one of those. Shows where the fires are. That's all I'm looking for. Yeah, fire maps. That's what we're looking for. That's what we're looking for. Where's the fire, man? Yeah, this website isn't too great. Yeah, we'll just look on Twitter for it. I think that's what we'll do. We'll just look on Twitter for it. Yeah, we'll look on Twitter for it. This is the best place to search for stuff. Wildfires. Canada. Look at wildfires. See what's going on. Also an earthquake apparently. Yeah. Like you have fires in British Columbia. That's what I was talking about. I'm just trying to get the alright, here we go. We get some sort of mouse simulation. Fire air now gov. Look at the simulation. We'll see what's going on. Yeah, some fires in Oregon it seems as well. On the coastline the smoke seems to go away. But farther inland the smoke is still pretty heavy. Keep looking at it. As you go into tomorrow, Monday, which is August 21st, smoke clears out inland, but those fires re-intensify, and you get more smoke that comes out. And that bit turn goes into Bend, Oregon as well. But yeah, the majority of the heavy smoke is east. It's east of is east. It's in eastern Washington and in British Columbia. That's where most of it is. Where is it, dog? I know I had like the videos for it. Like, where are they? I did like the videos for it. It's like one video, but that was like before. Oh my God, it's hard to do some of these videos, man. Or like live streams. It's hard to do them. There's just so much stuff that you have to look through. Yeah. Now, credit to the Michael guy who actually did this. I'll zoom out. Credit to the Michael guy. Credit to Michael Holsey. There's fires in. So look at the fires in West Kelowna, in British Columbia. So that fire spreads pretty fast over the time lapse. But yeah, the fires up there are pretty bad at the moment. With how much fire is going on, you can see them like right from the city. It's crazy. I just need to find an actual source though. Like, yeah, that's crazy. I don't think I have any copyright to any of these photos though. Yeah, I don't have any copyright to any of these. So the fire situation like Western Canada is pretty bad. So I will look at that if you live over there in that area. If you have smoke, so follow the tips I gave earlier. But if you know that you're in like an area where the fire is like not too far away, I would definitely try to evacuate as soon as possible. Because if you're stuck in a wildfire situation, you don't know how that's going to turn out. Also, flash flood warning in Yucca, California, I believe, as well. Yeah, earthquake in California. It actually is interesting. Light to moderate tremors. Okay. So they have an earthquake while they had a hurricane going on. While they have a tropical storm going on. Interesting. All right, so we'll close that and we'll get to like the final thing. There's not many people here, but we'll talk about like, you know what? I'll probably talk about this later. My God, my nose. I don't think anyone's here, but we'll still talk about what's going on with like long COVID symptoms. Use the biobot data. I'll leave a link to this in like the chat. But so this is the United States data that we have right now. So we're looking at this is the data over year for the past 4 years, really, from 2020 to